Hello students, let us try to understand atomic spectra students. Okay, this is the topic which we are planned to study today. Okay, so what is this student when you talk about the atomic structure, atomic spectra? So they are saying when an element is excited by some method such as by heating, bypassing electric current or bypassing electric discharge, the atom of the element emit electromagnetic radiation of definite frequency. Such arrangement of these radiation in the order of increasing wavelength or decreasing frequency is called emission spectrum of the element. Since the radiation in the spectrum are emitted due to energy change taking place in the atoms, this spectrum is also known as atomic spectrum. So they are saying that is since the radiation in the spectrum is emitted due to the energy change taking place in atom, this spectrum is also known as atomic spectrum. Now go for the another point. The instrument used for obtaining a spectrum is called a spectroscope or a spectrograph. In the spectroscope, light is passed through the prism through a prism and the emergent light is absorbed. It is well established fact that ray of light undergoes deviation when passed through a prism. The angle of deviation is directly proportional to the frequency of radiation. Thus, if we pass a beam of radiation having different frequency through a prism, this radiation unequal deviation undergoes unequal deviation and get arranged in order of decreasing frequency. For example, a beam of ordinary light is split into 7 colors after passing through the prism. So here they are saying there, student, see, in the spectroscope light is passed through the prism and the emergent light absorbed. It is well established fact that ray of light undergoes deviation when passed through prism. The angle of deviation is directly proportional to the frequency of the radiation. Thus, we pass a beam of radiation having different frequencies through the prism. This radiation undergoes unequal deviation and gets arranged in decreasing frequencies. For example, beam of ordinary light is split up into 7 colors after passing through the prism. Now see the phenomena of splitting of beam of light into radiations of different frequencies after passing through the prism is called the dispersion, and the pattern of radiation obtained after dispersion of beam is called spectrum. Okay, so this is what is the definition of spectrum. In case of dispersion of sunlight, the 7 color obtained change from violet to red without any discontinuity, which means each color bends into other. Such spectrum called continuous spectrum. In continuous spectrum, the radiation correspond to all the wavelength within a certain range are present. On the other hand, atomic spectra of most of the element consist of number of bright light separated by dark bands. That is why atomic spectrum is also known as line spectrum. That is what. On the other hand, atomic spectrum of most of the element consist of the number of bright lines separated by dark band. This is why atomic spectrum is known as line spectrum. The various lines in the line spectrum correspond to the radiation of different wavelength emitted by excited elements. These lines in the line spectrum of elements are characteristics of the atoms of the element. Therefore, atomic spectrum of element can be used to identify the element and is sometimes called the fingerprint of atoms. German chemist Robert Bunsen, 1811 and 1899, was first scientist to use the line spectra to identify element. Elements like rubidium Rb, cesium Cs, indium In, scandium Sc, etc. were discovered when their minerals were analyzed by spectroscopic method. The element helium was discovered in the sun by study of the spectrum of sunlight. Now we are going for a study the absorption spectrum. When a beam of a continuous light is passed through a tube containing vapors of the solution of the substance, and the transmit light no, no, what they are going to do, student, and the transmit light is analyzed with the help of the spectrometer. It is observed that the spectrum obtained contains a number of dark lines in otherwise continuous spectrum. These dark line appears due to the absorption of radiation of corresponding wavelength by the substance. The dark lines in the absorption spectrum of a substance appear at the same position as the bright lines in the emission spectrum of the substance. For example, emission spectrum of the sodium has two bright lines in the yellow region 589 nanometer, 589.6 nanometer, whereas its absorption spectrum has two dark lines corresponding to the same wavelength. Generally, more lines are absorbed in the emission spectrum than it is absorption spectrum. Therefore, absorption spectrum taken is simplification of the spectrum. So this dark line is implies that the absorption spectrum. Let's see, student. Again, you can read out the statement. When a beam of continuous light is passed through a tube containing vapors of solution and substance, and the transmitted light analyzed with the help of the spectrometer, it is observed that the spectrum obtained contain number of dark line, otherwise continuous spectrum. These dark line appears due to the absorption of radiation of the corresponding wavelength by the substance. The dark line in the absorption spectrum substance appear at the same position as the bright light in the emission spectrum of the substance. For example, emission spectrum of the sodium has two bright lines, yellow and yellow, that is 589, 589.6, whereas absorption spectrum has two dark lines corresponding to the same wavelength. Generally, more lines are absorbed in the emission. So that is what the black color is. This is the absorption, and bright is that is emission spectrum. Now, the next one is, let us try to understand hydrogen. The atomic spectrum of hydrogen has proved quite helpful in the development of the atomic spectrum. It can be obtained by passing the light being emitted from the discharge tube containing hydrogen at low pressure through the spectrograph as shown in figure. So this is the dark band, line band spectrums are there. When an electric discharge is passed through the hydrogen gas, its molecule dissociate into hydrogen atom. The excited hydrogen atom thus emit electromagnetic radiation of discrete frequency. The spectrum obtained consists of large number of sharp lines. Each line corresponds to a particular frequency of light emitted by hydrogen atoms. Line in the emission spectrum of hydrogen are present in ultraviolet, visible and infrared region, while the line in the ultraviolet and visible region can be directly obtained on photographic plate. The line in infrared region are detected by other methods. So the line of the emission of spectrum of hydrogen classified 5 series: Lyman series, alpha violet; Balmer series, visible region; Paschen infrared region, bracket infrared region, and that is P fund is also infrared region. So this is the Lyman series, Balmer, Paschen, P fund, now bracket and P fund. These are. Balmer shows in 1885 that the spectral lines are expressed in terms of the wave number, inverse of the wavelength. Then the lines in the visible region, Balmer series, obey the formula. What is nu bar is equal to 109,677 by 2 square minus 1 by n square, where n is the integer, equal to 3, 4, 5. Later, Rydberg give more general formula which is applicable to all the series in the hydrogen atom. So this is what n1 minus n2 square. This is what. So this is all about what is stored in the hydrogen spectrum. Thank you so much for watching.